Something that you talked about in geometry were two of our special right triangles. Those two special right triangles are the 45, 45, 90 triangle and the 30, 60, 90 triangle. Those two triangles always have the same ratio of sides. I don't know exactly how you talked about it, but if you have a 45, 45, 90 triangle, let me just draw one over here. Okay, let's pretend that's a 45, 45, 90 triangle. If these are both 45 degrees, that means the two legs have to be equal. So the simplest thing this could be is 1 and 1. And then the hypotenuse is the square root of 2. So a 45, 45, 90 triangle always has sides in that ratio, 1, 1, root 2. Now, if the two legs are not 1, they could be anything. Like if it's 7 and 7, then this would be 7 root 2. So another way we think about this is here. If the sides are both x, then the hypotenuse is x root 2. Okay, but that's the same ratio as 1, 1, 1 root 2. The 30, 60, 90 one is a little bit more complicated. Let me draw one of those. Okay. I mean, it's just a tiny bit more to remember, I guess. The sides of a 30, 60, 90 are 1, 2, and root 3. You need to know those. Now, where they go, the 30-degree angle, that's the smallest one. So across from it gets the smallest side. The hypotenuse across from the 90-degree angle is the biggest. The biggest number is 2. And so that means across from the 60-degree angle is the root 3. Okay, so those are sides of the 30, 60, 90. 1, 2, and root 3 in that order. Again, it doesn't necessarily have to be 1, 2, root 3, but they're always going to be in that ratio. So another way to write it is 1x, 2x, and x root 3. You need to know these. Next week, we're going to be using these very extensively to solve some other types of problems. Usually I use this version, the 1, 1, root 2, and the 1, 2, root 3 versions of it. That's what I want you to know. For the problems we're doing today, we're going to use the x root 2, but it is the same thing. So like I said, put a star by this, circle it. We're going to be dealing with this a ton. So we're going to use those special right triangles to find the missing side lengths. We can kind of take some shortcuts here. It's fine. I'm going to start on the second one here. This is a 45, 45, 90, which means these two sides have to be equal. So if that side's 17, then this side is 17. And remember, we said that the ratio was x, x, x root 2. 1x, 1x, x, 1x root 2. Now, instead of 1x, we have 17. So instead of 1x, we have 17, 17. So this side is going to be 17 root 2. Okay, and that's all we have to do with that one. You could have also found that using Pythagorean theorem. Just remember, we want exact values, no decimals here. Okay, so let's check out this other one. I'm going to change these. I'm going to call them A, just because I don't want X's. Since these are the same, that means these angles have to be same. So this is another 45, 45, 90 triangle. Okay, we know that 45, 45, 90 triangles have this ratio of x, x, x root 2. Now, we don't know what x is. We don't know what a is. We have to figure that out. But we do know that this x root 2 is equal to 8. In case you can't see that, that's an 8. So if we want to solve this for x, we're going to divide by root 2. So we get x over root 2, which I'm going to go ahead and rationalize, times root 2 times root 2. So we get 8 root 2 divided by 2, which is going to be 4 root 2. So we have just found out that x is 4 root 2, and x is equal to a. So that means that this side is 4 root 2, and this side is 4 root 2. Let me circle those. So our two sides are 4 root 2, 4 root 2, and this side is 8. And they are still in that ratio. All right, let's try the next one. I'm going to change these letters to A and B just so we don't get confused with the X's. It's fine. All right, this is a 30, 60, 90 triangle. So let's put in our ratios. So across from the 30-degree angle is 1x. The hypotenuse is 2x. And the other side across from the 30-degree angle is x root 3. Okay, those are the ratios. Now, we want to find out what a and b are. B is equal to 2x. We don't know either of those. A is equal to x root 3, but we do know that 1x equals 2. So this tells us that x equals 2. So if we plug that in over here, 2 times 2, that makes this side 4. And if we plug that in over here, this is 2 root 3. So the sides of this triangle are 2, 4, and 2 root 3. All right, we'll use those ratios one last time on this triangle. I'm going to call those sides A and B. This is a 30, 60, 90 triangle, so I'm going to put in those ratios. Across from the 30-degree angle is 1x. Across from the 90-degree angle is 2x. And across from the 60-degree angle is x root 3. So we know that b is equal to x root 3, which I don't know what x is yet. A is equal to 1x. I don't know what x is. And 18 is equal to 2x. Oh, I could solve that. That is going to, if I divide both sides by 2, that's going to tell me that x equals 9. And since a equals 1x, that tells me that a equals 9. And since b equals x root 3, that tells me that b equals 9 root 3. So the sides of this triangle are 9, 9 root 3, and 18. Okay. We'll be dealing a lot with special right triangles, like I said, particularly the simplified version, the 1, 2 root 3, and the 1, 1 root 2. Okay, so make sure you know those. And then these problems, we were just using those ratios. In the next video, we will just talk about some applications of SOHCAHTOA.